Good day everyone, this is Lindilans M. Lecaros. I'm going to present to you the process selection and facility layout. Process selection. It refers to deciding on the way production of goods or services will be organized. The processes convert inputs into outputs. The process selection affects the entire organization and its ability to achieve its mission and effective supply chain system. Basically, the processes are vital to any organization. The key aspects help in process selection are the capital intensity and the process flexibility. Capital intensity is the mix of equipment and labor that will be used by the organization. The process flexibility is the degree to which the system can be adjusted to changes in processing requirements, factors such as changes in product design, volume, process, and technology. The questions when we want to select a type of process are 1. How much variety in product or services will the system need to handle? 2. What degree of equipment flexibility will be needed? 3. What is the expected volume of output? For example, one food product has varieties, 5 spicy flavors, 8 sweets, and 10 original flavors. These are the amount of varieties that we need with the help of our flexible equipment. Another example is you may encounter a snack food that says this may contain milk or peanuts. This possible containment may be caused by equipment sharing of the varieties. This is an example of process flexibility. Now, capacity planning and process selection are interrelated. This process selection and capacity planning are used in the following: forecasting, product and service design, technological change, facilities and equipment, layout, and the work design. Forecasting. We consider the expected output or demand. The product and service design, we consider the type of process for the varieties. Technological change, we consider the adaptation to a more efficient process. Facilities and equipment, we consider the warehousing capacity and equipment functionality. Layout, we consider the effective and efficient flow of the products, and the work design, it is a more about job functions of the employees or workers. We will now proceed to types of process. Number 1 is job shop. It usually operates on a relatively small scale. It is used when a low volume of high variety of goods or services will be needed. Here, the processing is intermittent. The work includes small jobs, each with different processing requirements. The important characteristics are high flexibility using general purpose equipment and skilled workers. The example here is the hospital medical services. Number 2, batch. It is used when a moderate volume of goods or services is desired. Also, it can handle a moderate variety in products or services. The equipment need not be as flexible as in a job shop because there is less variety in the jobs, but processing is still intermittent. The example here is bakery, which makes breads, cakes, and cookies in batches. Other examples are plain carrying batches of people or a classroom, lecture, concerts, and many more. Number 3, repetitive. When higher volume of more standardized goods or services are needed, repetitive processing is used. Standardized output means only slight flexibility of equipment is needed. The requirement of skilled workers are generally low. For example, is a manufacturing plants producing pencils, automatic car wash, cafeteria lines, and many more. Number 4, continuous flow. When a very high volume of non-discrete, highly standardized output is desired, a continuous system is used. These systems have almost no variety in output and hence no need for equipment flexibility. An example here is a factory producing sugar, flour, salt, and even internet services. And number 5, project. A non-repetitive set of activities directed toward a unique goal within limited time frame. It is used for work that is not routine, with a unique set of objectives to be accomplished in a limited time frame. The equipment flexibility and worker skill can range from low to high. Here you can see an example of a construction of a dam. Other example is a filmmaking with an output of finalized film. Automation. It is a machinery that has sensing and control devices that enable it to operate automatically. Automation. It can range from factories that are completely automated to a single automated operation. Nowadays, services are also enjoying automation like banks' ATM system. It is frequently pushed as strategy necessary for cost competitiveness. Automation offers a number of advantages over human labor. 1. Low variability, where it is difficult for a person to perform a task in exactly the same way in the same amount of time. 2. Machines don't stop or get distracted, nor they go out on strike as for higher wages or for labor grievances. The disadvantages of automation over human labor is 1. Technology. Technology is very expensive. It usually requires high volume of outputs to offset high costs. 2. Automation is much less flexible. Once the process has been automated, there is substantial reason for not changing it. Before automation, careful planning is necessary to successfully integrate automation into the production system. Now we proceed to types of automation. 1 is fixed automation, 2 is programmable automation, and 3 is flexible automation. Fixed automation. It is the most rigid type of automation. It uses low-cost specialized equipment for fixed sequences of operations. Low cost and high volume production are its primary advantages. Minimal variety and the cost of making major changes in either product or processes are its primary limitation. Programmable automation. It involves the use of high-cost, general-purpose equipment controlled by a computer program. The computer provides both the sequence of operations and the specific details about each operation. It has capability of economically producing a fairly wide variety of low-volume products in small batches. An example here is a robot. It is a machine consisting of a mechanical arm, a power supply, and a controller. It can handle a wide variety of tasks including welding, assembly, loading and unloading of machines, painting, and testing. Flexible automation. Flexible manufacturing system is a group of machines that include supervisory computer control, automatic material handling, and robots. This system can range from 3 to 4 machines to more than a dozen, capable of reducing labor costs and maintaining the quality constantly. Requires less capital investment and offers high flexibility than fixed automation. It helps achieve both the flexibility of job shop processing and productivity of repetitive process systems. Now we proceed to facilities layout. The types of facilities layout are product layout, process layout, fixed position layout, and combination layout. Facilities layout is a configuration of departments, work centers, and equipment with particular emphasis on movement of work, customers, or materials through the system. The objectives of layout design are facilitate attainment of product or service quality, use workers and space efficiently, avoid bottlenecks, minimize unnecessary movement of workers or materials, minimize production time or customer service time, and are designed for safety. Here are the illustration of a product layout and process layout. The product layout begins with station 1 to station 2 until the last station. Each station consists of materials and or labors for the creation or delivery of the product. It is used for repetitive or continuous processing. Product layout uses standardized processing operations to achieve smooth, rapid, and high volume output. The process layout, also known as functional layout. It is commonly used for intermittent processing like job shop and batch. This layout can handle the varied processing requirements. The process with a functional layout is this way, from department A to B and then to E, or from department A to C to F and then back to A again. Fixed position layout, a layout in which the product or project remains stationary and workers, materials, and equipment are moved as needed. In example, road building or house building. Line balancing. It is the process of assigning tasks to workstations in such a way that the workstations have approximately equal time requirements. This way, the idle time will be minimized and utilization will be maximized. Precedence diagram. It is the tool used in the line balancing to display elemental tasks and sequence requirements. A simplified precedence diagram is that when we add A and B, we get 1.1 minutes, while C and D we get 1.2 minutes. But adding D and E would not balance approximately to A and B because of 0.7 minutes of D and E. Again, line balancing is about distributing approximate equal time requirements to each workstations. Cycle time. It is the maximum time allowed at each workstation to complete its set of tasks on a unit. It can be computed by dividing operating time per day to the desired output rate equals the cycle time. The maximum time must be less than the cycle time, and the cycle time must be less than the sum of times or task times. Cellular layout. It is a layout in which machines are grouped into a cell that can process items that have similar processing requirements. This is like all the processes needed are in one place, like how mitochondria and nucleus work together in one cell. An illustration here shows the product and process layouts. The before represents the process layout or functional layout, while after represents the product layout or cellular layout. Here are the differences between functional and cellular layouts. When it comes to number of moves between departments, the functional layout requires many moves, but the cellular layout requires fewer. The cellular layout has shorter travel distances. The travel paths are fixed, job waiting times are shorter, and many more. Basically, the cellular layout is more efficient than the functional layout. And this is the end of my presentation. Thank you for watching.